Okay, so now we need to know how to use a perceptron or a linear model for multi-class classification. So, I mean, last time, if you remember, we used a perceptron for binary classification problem, and it was very simple. But this time we need to know, is there any way to use a linear model, such as a perceptron for classifying multi-class classification? So we will learn how to do this. So many linear classification models are for binary classification only and don't extend naturally to the multi-class classification. So it can be used only for solving binary classification problems, but we will learn here how to try to expand this model to solve multi-class classification problems. So a common technique is to extend this binary classifier to a multi-class classification algorithm is the one versus rest. So we will use this technique, which is called the one versus rest approach. OVR. In this OVR approach, a binary model is learned for each class to separate that class from all other classes. So we will try to get a model to separate each class from the rest of the dataset or the rest of the other classes, resulting in as many binary models as there are classes. So so having one binary classifier per class. So at the end, we will get one binary classifier per each class. So if you have three classes, for example, like Iris dataset, in Iris dataset, we have three classes. So in this case, we should expect that we will get three classes. Three classifiers, one for each class. So we will get one binary classifier per class, resulting in a vector of coefficient and one intercept for each class. So we will get, instead of getting one vector, it will be a matrix, in fact. So because each model will have one vector of weights and one intercept. So in this case, we will get three models. For example, if we need to use binary linear model for classifying Iris dataset, the three classes, we should expect that we will get three classifiers, one for each class. sklearn provides a sample dataset generator to help you to create also fast and easy to use custom datasets. I mean, sklearn has its own sample dataset generator, which can be used also for generating your own dataset and try to build a classifier for those custom datasets. So just an example, we have a function called the make_plups. This function called the make_plups, it generates isotropic Gaussian plups for clustering. It should be like this one. So for example, you can use this function for generating, say, three classes, for example, and also it will control also the overlap between those classes. So it has some parameters. Using those parameters, it should be able to generate more complex classes, which are overlapping and complex to classify, for example. So, similar to this dataset, for example, we can see that we have here, it's easy. So I need to get a model to classify the CL1 against the rest. I need to get another model to classify this one against the rest, and so on. So at the end, we will get like three classes, for example, right? But you can also try to make it more complex by increasing the overlap between those classes, as you can see in this graph. So we will use this function, which is called the make_plups for creating our own dataset. We will try to generate three classes. We have here class 0, this one class 0, this one class 1, and this one class 2. As you can see here, we have very long distance between classes. So it's easy to classify it using a linear classifier, linear or binary classifier. So for example, we need to get a model. I will draw it with, so for example, if I need to classify the green one, right? So if I need to classify the green one, so I need to draw a line like this one, correct? So this one will classify class 1. So this one will classify the green one against the rest. So all data points which are above the line will be classified as green. all other data points will be classified as the rest. And for the red one, I need to get a model like this one, correct? And for the blue one, it will be also like this one. So in this case, we will get 3 models. This is model number 1. This is model number 2. And this one will be model number 3. So model number 1 will classify the green one against the rest. Model number 2 will classify the red against the rest. Model number 3 will classify the blue one against the rest. So, I mean, this technique, it's called one versus rest. One versus rest. It's a very important technique, and we can use this technique to extend linear classifier to solve multi-class classification problems. And as you can see here, each class will be a perceptron, and each class will have 2 inputs and 1 bias. So should expect that the classifier which will classify class 0, it will have omega 1, omega 2, and a bias value. This is model number 1, right? This is model number 1. For model number 2, it will be like this one. So we have omega 1, omega 2, and B. For model number 3, it will be the same. We will get omega 1, omega 2, and B. So in this case, we can use binary classifier for solving this problem. I will explain the code, or maybe we can go to the code directly. Yes. So I will just explain it, and after that we will go for coding. So first we need to generate our own dataset, and we will do that using a function called makeblobs. You see this function makeblobs? We import it from sklearn.datasets. So we have makeblobs from sklearn.datasets. We will use it for generating our own custom dataset. So makeblobs, it will generate x and y. You can use random state equal 42. So in this case, each time you run the function, you will get the same set of x and y. X will be the input target features, and y will be the labels. You will do it, and it will generate 3 classes, and we will plot the dataset using plot, and we can see the dataset. After that, you need to build a model. We will use logistic regression. In case of logistic regression, you don't need to use one versus the rest, because it is able, in fact, to solve multi-class classification. So this is our model, logistic regression. And after that, we will use the whole x and the whole y. Remember, we need to split, but I make it very quickly, but we need to go back to last slides, and we need to split our x and y into x train and y train, x test and y test. But for simplicity here, I will just use the whole x and the whole y for training my model. And after that, I will test my model using x to get y predict. From y predict, subtracting y predict from y, you will get the prediction error. And after that, you will print your model coefficient and model intercept. If you want to plot the decision line, I mean, we know this, but in this case, we will have for loop because we have 3 models. Remember here in logistic regression, it will generate 1 model for each class. So if you want to plot your decision line, I need to put it in a for loop. So this model coefficient and the model intercept, this one, in fact, it will include the coefficient of 3 models or 3 perceptrons. So we need to use a for loop to get the coefficient and the intercept from each model. And you need to generate x1 as we did before using line space, for example, from -10 to 10. So I will get x1, and I will substitute x1 into this equation to get x2. So if I need to plot it like this, the model will be like this one, right? So we have here omega 1, omega 2, x1 and x2, and we have here +1 b. So this is my model, my first model. So net value here, it will be omega 1 x1 plus omega 2 x2 plus b equals 0. If you have x1, I need to get x2. So x2 will be 1 divided by omega 2 multiplied by minus omega 1 x1 minus b. So this is the equation here, right? This is the equation. So in this case, I can plot the 3 decision lines. And when we do this, we will be able to plot the 3 decision line. It's not here, but so by default, this function makeblobs, it will generate 3 classes. I mean, by default. So this one by default, it generates three classes. Generates three classes, right? If you want to customize it more, you can just define number of centers here. Number of centers. When number of centers equal 4, it will generate 4 classes instead of 4 or 5, as much as you want. And we have this cluster standard deviation. This is the distance between. This is the distance. It will control the distance between different clusters. So in this case, we have 4 classes. You will use a logistic regression one more time, and it will be able to generate those 4 models, right? So now we have one model for green, one model for red, one model for blue, and one model for purple, right? We have 4 models. And in this table, we have the parameters and the bias of each model. So I want to use this approach for iris dataset. Okay. We will go back to the, but I will just explain it quickly, and after that we will go for coding. So extending a perceptron for multi-class classification. Because remember last time when we solved this for perceptron, we used 2 inputs. And we used one perceptron for classifying into class 1 and the class 2. If you want to use a perceptron for iris dataset as a multi-class classification, so it will look like this one. We have 3 classes: Setosa, Versicolor, and Virginica. We have 3 classes. In this case, we will use the whole dataset, which is 150 data points. So the model will look like this one. Correct? The model will look like this one. We have 2 inputs, x1 and x2. So the first model will classify class 0, class 1, and the class 2. It will look like this one. And we should be able to get model parameters like this one. One for each, one line, one row, in fact, for each model. So for model number 0 or number 1, for example, we will get those weight omega 1, omega 2, and bias. For the second one, this is omega 1, omega 2, and the bias. For omega 3, this one will be omega 1, omega 2, and the bias. So in this case, we can use a perceptron for multi-class classification. So and here, if you want to draw the decision line, for example, we split the data. I mean, here we use the iris dataset, right? From datasets.load iris, we will get iris. We will use feature number 2 and feature number 3, or 3 and 4. Y equal iris.target. So the input targets, input features, and the target features will be like this one. So we will use here beta length and the beta width. And we have 3 classes. As you can see, this unique of Y, it will be 0, 1, and 2, which means we have 3 classes. Labels or target names, it will be Setosa, Versicolor, and Virginica. And the feature names, sepal length, sepal width, beta length, and beta width. And as you remember, we use this 2 and 3, in fact. So this one, it's input feature number 0, this one number 2, this one number 3, this one number 3, 2 and 3. So we selected 2, those 2 as the input. We used it from data pre-processing. We use the standard scalar or normalization. We know this, the meaning of this one. And after that, we will use train test split from model selection, train test split, because we need to split our data into one for training, one for testing. And we will use the test size equal 0.3, random state equal y, so we can generate the same set each time when we run that part. Stratify equal 1, and it's important because we need all classes, all the Slaker classes, as you can see here, to be equally represented, as you can see here. So in the Y train, it has 35 from class 0, 35 from class 1, 35 from class 2. And for the Y test, it will be 15 from each class, as you can see. So it's all classes are equally represented. So we selected a perceptron from model selection, or from linear model, we selected a perceptron. So this is my model. And we will train the model using X train and Y train. And we will use X test for calculating Y prediction. Correct? And after that, we will print model parameters. We will print model coefficient and the model intercept. So we get those. So in fact, the model accuracy here for multi-class classification, we have model accuracy is 95%. I just calculated the accuracy using 2 approaches. using this function, which is model.score. The input to this function will be x test, y test. I calculate the accuracy for test set. So the input to this function will be x test, y test. Multiply it by 100 to be in percentage. So this is one way for calculating your model accuracy using this nice function, model.score. And if you want to use our traditional approach, I need to calculate the prediction error, which will be number of cases where y test not equal to y predict, or y predict minus y test, right? Take the summation and subtract this one from my total length of y test and divide it by the length of y test. Or just try to use this y predict minus y minus y predict square. So yeah, so now we will go to the code and we will try to run it in Google Colab step by step, so we can solve this one. So now we will go back, and we need to go back and try to run this code. Okay, so we will start with this one. In this example, in fact, we need to use Makeplups for generating some customized data set. For example, we will use this Makeplups, and we will use a linear model. We will use logistic regression, which is a type of linear model. So we will run that part. So now we will try to generate our custom datasets. We selecting centers equal 4, cluster standard deviation equal 1.5. And we do this, in fact, because we need to generate something customized. So we assume that we have 2 inputs. So this is x1 and this is x2. And we will try to generate something like this one, 4 classes. So centers equal 4, so which means we will have 4 clusters. And this standard deviation, this one, it will control the distance. If you want to make it very challenging, try to reduce this number, so you can get some overlapping between those clusters. Now we will plot our data for those 4 classes. So we will get this graph, as you can see. And also, okay. So it will be 100 points. I mean the total number. So the data set will look like this one. It will be a table like this one. It will be like this one, right? So we have here x1 and x2, and this is my target. So, and the size of this data set, it will be 100 points or 100 examples. Each 25 represent 1 cluster. So it will be like first 25 would be 1 cluster, second 25 would be another one, third, and it will be like this one. So this one will be cluster number 0, this one will be number 1, this one will be number 2, this one will be number 3. So it's a multi-class classification. So 25 from each cluster. How can we know this? Using yes, bin count. You can just bin count y. If you can bin count y, if you can bin count y, it will give you number of examples in each cluster or in each class. So bin count y, it will give you number of examples in each cluster or in each class. Right, so this will be cluster number 0, this one cluster number 1, 2, 3, and so on. Yes. So so now we are plotting our data. Now we need to build a model. We will use logistic regression. We need to use logistic regression model, and we will use it for multi-class. So multi-class equal OVR. We will use this technique, which is one versus rest. We will use multi-class, which is one versus rest. OVR means one versus rest. So we didn't split the data here. As you can see, we just use the whole X and the whole Y for training the model and for testing. So just remember, you need to split. Use train, test, split. We need to use train, test, split. The input to this function will be X and Y, and the output will be X train, Y train, X test, and Y test. Right? So it will be like, I mean, if you want to move, I mean, if you want to go forward correctly, we need to split. But I just made it here like this for simplicity. So now we trained the model, we defined our model, which will be logistic regression, and we will use it for solving multi-class classification using one versus rest. I used X and Y for training my model using model.fit, and the model.predict, I will use also X for testing as a test set. So we will get Y prediction. You can use this function for getting the accuracy directly, model score of X and Y, right? It will give you the model accuracy, which will be, of course, 100%. Why it's 100%? Because we used the whole X and Y for training our model. After that, you can print model coefficient and the model intercept. Model coefficient, it will return omega 1 and omega 2 for each model. And the intercept, it will return as a bias for each model. In this data set, we have 4 models or 4 classes. So should expect that this omega, what will be the size? It will be 4 times 2. Because each model has omega 1 and omega 2. And we have 4 models, 1 for each class. And the bias, also, it will be 4 values. It will be a vector of 4 times 1 times 4. So it will be this vector. So this one is the bias, and this one, it's omega. So now if I want to plot my model, it will look like this one. One model for each class. So I can just, this is class number 0, this is class number 1, this is class number 2, against the rest, this is class number 3. How many inputs we have? We have 2 inputs, x1 and x2. Those x1 and x2, it will be connected to each model. So and you have those numbers. So for the first model, and remember you have the bias. So for example, for this model, first model, it will be this number, 0.5. This one will be 0.5. This one will be 1.3. And the bias will be minus 8.256. So it will be like this one. So now we have the model, and we have the parameters of each model. So now if we need to plot the decision line, how can we do this? Right, so we just need to plot this one using a for loop, because we need to get the coefficient and the intercept for each model, right? So just remember that this one the decision line will be omega 1 x1 plus omega 2 x2 plus p equals 0. If you have x1, you need to get x2 from this equation. So x2 will be minus 1 divided by omega 2 multiplied by omega 1 x1 plus p. So if you have x1, you can substitute x1 in this equation to get x2, and after that plot x1 against x2. So we will do it in a for loop. Why in a for loop? Because we have 4 models. So we need to get the model coefficient, model intercept for each model, and just substitute, define x value and substitute x value in this equation to get x2, and after that plot x1 against x2, and that is it. So at the end we will get this graph. So now in this graph, you have this cluster which is green, and to classify this green one against the rest, we used this green model or green decision line. I will call it model number 0. And for the red one, we will use a red model to classify this red cluster against the rest of the whole data. Right? And for the blue cluster, this one, we will generate this model which will classify only the blue one against the rest. And for the purple cluster, we will also get this model. So at the end, we have 4 models, right? At the end, we will have 4 models, 1 for each class. So in this case, we used a linear model, which is very simple. It's just a regression model or a perceptron for classifying each class against the rest. So this technique, we call it one versus rest. In fact, if you want to solve this problem, it requires more complex feed-forward neural network. So for example, we have 4 classes. So at the end, we need to get in the output layer. If I need to draw a feed-forward neural network or a multi-layer perceptron, so it should be like this. So we should have an output layer which have 4 units. So it would be like this one. Correct? And there may be another hidden layer and an input layer which has 2 inputs or 3 inputs. It should be something like this one. We have here 2 inputs, x1 and x2. We will connect. Correct? Connect all those connections. Right? And make those connect. It will be a very complex model. It will be a very complex model if we need to solve it using a feed-forward neural network. But in our case here, we just solve it using 4 perceptrons. So in fact, as a problem, it's complex if you want to solve it using a multi-layer perceptron. But using this beautiful technique, which is called one versus rest, we were able to solve this problem using a linear model. So we have a linear model, and we use the linear model for solving such complex problems. So please, if you have any questions, you can just ask. And if you don't, we will go to the next link. So we can open. Yes, we need to delete this one, clean. Yes. So this is MakeBLUPS. So we used it for 4 classes, as you can see. We used this MakeBLUPS for generating 4 classes. And we used linear regression model for solving this problem using this one versus rest. Right? This one is very, very important. We can solve with a model. We can get access to the model parameters. We can plot the decision lines. So now we need to go back to iris dataset and try to use the same technique for classifying this iris dataset using a perceptron, using this one versus rest technique. So we need to use a linear model for solving such complex problem. So we will go to the link. Yes. So perceptron for multi-class classification. So we will run that part. And we need to load iris dataset. We will load whole iris dataset. Do you remember? Do you see that part? We will load iris dataset from datasets.load iris. We will select the betal length and the betal width as input features. Why we are doing this? We are doing this because I need to plot it in 2-dimensional space. If you want to plot it in 3-dimensional space, you can select a third one. And those are my iris, my target features. So we have X and Y. So we have 3 classes, 0, 1, and 2. Now we have 3 classes because we used the whole data set. So Y now consists of 3 classes, 0, 1, and 2. The names of the target labels, it will be Setosa, versicolor, and virginica. Feature names, sepal length, sepal width, petal length, and petal width. So now we need to, if you want to use standard scalar or normalization, it's okay. If you don't want, it's fine also. So that step here, standardize your feature vector. You can do it, or you can just ignore it, for example. In fact, usually we standardize and also normalize. So it's better to do normalization and standardization. Now we will use a split, to train test split, to split my data into training and testing. So from this sklearn.model selection, we will import this nice function, which is called the train test split. This function will be used to split my data into one part for training, one part for testing. So it will be like this one. This is my whole data set, which is 150 points, right? The first part, it's a class 0. We have here one part, which is class 0. The second part is class 1, and the third part is class number 2. We have 3 classes. So we will use this function, train test split. So we will use random state equal 1, for example, test size equal 0.3, which means the data will be divided into 70% for training, and 30% will be used for testing. We will use stratify equal y because I have 3 classes, and I want to be sure that the 3 classes will be equally represented in the training and testing sets. So we will do this. So we will get x train, x test, y train, y test. If you can bin count of y train and y test, bin count of y train, it will give you this one. And the bin count of y test, it will give you this one, which means in the training set, 35 from class 0, I will have 35 from class 0, because here, in fact, it's 50 examples. This one, it's 50, 50, 50. And we divided it into 70% training and 30% testing. So in this case, we will have 35 will be used for 35 plus 15, it's 15, correct? And 70% of 50% of 50, it will be 35. So it will be divided. Each one will be divided into 35 for training and 15 for testing. This one, 35 for training, 15 for testing, and so on, right? When we use stratify equal y, we try to stratify y to ensure that the 3 classes will be equally represented in the training and the testing sets, as you can see here. After that, we will select a model. After that, we will select a model. We need to clean. I will select a perceptron or a logistic regression, for example. It's up to you. Here we used, in fact, we did it twice. So I have 2 models, model 1 and the model 2. So model 1 will be a perceptron. Model 2 will be a logistic regression. And when it is logistic regression, remember to add this multi-class equal OVR. I will train the first model using X train, Y train. In case of perceptron, you don't need to write multi-class equal OVR because it will understand it automatically from the data from Y train. So when it sees that in Y train we have 3 classes, so it will automatically use OVR. So model 1, we will train model 1 and model 2. We will get Y predict 1 by testing model 1 using X test and testing model 2 using X test. We will calculate model score. So model 1 dot score, X test, Y test, model 2 dot score, X test, Y test. And we will try to print out the accuracies. So perceptron has an accuracy of 95, as you can see here. So this is the accuracy of model 1, which is a perceptron, which is 95. So this is a perceptron, 95.6% for the test set. So this is the accuracy for the test set. And for the logistic regression, the accuracy was 97.8%. So it's clear that logistic regression performs much better than a perceptron. A number of misclassified sample for the model 1, only 2 misclassified. And for model number 2, it's only 1. So the accuracy of model 2 is much better. If you want to see if you want to get model parameters, you just need to print it. So it will be like this one, model 1 dot coefficient, model 1 dot intercept. You can do this for perceptron, for model 1 and for model 2. So we got this matrix of weights, this one. So this matrix for the perceptron, and this vector for the bias. This one, it's bias. Those are for the weights. Why it's like this? Because the model looks like this one. We have 3 models because we have 3 classes. This one will be class 0, this one will be class 1, this one will be class 2. We have 2 inputs, x1 and x2, connected. So it will be this one, omega 1, omega 2, and this is bias. So for model 1, omega 1 equals this value, omega 2 equals this value, and the bias equals this value. For model number 2, and so on. So in this case, we can get all those numbers. If you want to plot the decision boundaries also, so just you need to repeat it as we did before, right? So just to define a function and to try to put it in a for loop, for example, and to try to decision. I mean, this is plotting the decision boundary for model 1, for example, just to make it for one model and to try to call it 3 times, for example, right? So we will get x1 and x2. I used here mesh grid, right? I just used here mesh grid approach. So it will be like this one. We will have x1 and x2. We will plot this grid. And we will send all those points to the model 1 for prediction. So it will be classifying, it will classify those points into class 1, class 2, and class 3, right? Because we have this model. In fact, it has 3 models, correct? This model consists of 3. So we will generate those points. We will send all those points to the model. And this model, it will return the class, which will be one of the 3 classes, right? So it will be like this one. This is for model 1, and this is for model 2, correct? So we will generate all those points, all those grid points. We will send all those points. If those points are located above model 1, in the area of model 1, it will be classified into blue. If it is located in model 2, it will be classified into purple. If it is in the area for class number 3, it will be classified into red, and so on. So this is a very nice approach and a very easy approach for doing this. So now, I mean, today so I will stop here today. In fact, we will not take any more things today, but I can just share the links with you. Or I can send you the slides. In fact, I can send you the PowerPoint. So you can try to get links and try to work with those examples. So we will stop here today. I will stop live streaming. So we can work on some examples together, or I want you to have time to work with those examples. So I will stop.